Hey guys, it's Stephen Gates here from myplctraining.com, and we got another video today to help you become a confident PLC programmer. And today we're talking about Modbus, which is a really important part of understanding industrial automation because it's still used a lot for communicating between devices, especially PLCs and similar devices. So I'm just going to dive right into this. We gave you an intro last week via email, but we're going to cover some of that again here. So Modbus is an old industrial communications protocol, and it allows for the transmission of data among PLCs and or other industrial devices like drives or power meters. And believe it or not, this protocol has been in use since 1979. So it's obviously stood the test of time, and this is most likely because of how simple it is to use and the fact that it is open source, meaning any company or individual can build in Modbus communications into their PLC products or other industrial devices that they're developing. So a lot of people have done that, and over time it's become one of the industry standards for industrial communications. So in this video we are going to use a simple example of how you could use Modbus to gather data from a thermostat into a PLC and then pass it on to an HMI. So we're not going to go into the HMI side of things, but these are data points that we're going to get from a thermostat that you could easily display on the HMI. So this example builds on an example, again, like I said, that I sent out in an email recently. And if you'd like to make sure you get those emails when they get sent out, you can sign up for our newsletter and get the free PLC cheat sheet that we have using the link below in the description, or just head over to myplctraining.com and you can get it there. Okay, so here's this very basic graphic that I drew here just to give you an idea of what we're doing. So we're going to try to get some data from a thermostat, which is not your typical industrial device, but everyone understands thermostats usually, so I thought I would use that as an example. And we're going to get some data from the thermostat into a PLC, and then we could use this data in the PLC to send it to an HMI screen. So in our example, we said that we want to read the room temperature from the thermostat and whether the thermostat is calling for heat. So if the temperature gets to a certain set point or to a certain level and the set point is set such that it wants to turn on the heater, then we want to know if the thermostat is doing that. We also want to send a signal to the thermostat once a day to turn on a fan that it controls for 1 hour. So we're not going to get to that one right now, but that's another command we could send to the thermostat. So we're going to read something from it, the room temperature, and then we're going to send something to it, particularly a command to turn on a fan to circulate air in the room. So we're going to use a configuration tool, a Modbus configuration tool from Prosoft, which if you're using Allen Bradley PLCs and you need to use Modbus alongside the PLC, most likely you will end up using Prosoft device. So if we scroll down here on this document I have, here's an image I got from Prosoft's website of the PLX31 EIP MBS, and it's a go-between Compact Logic's controller talking over Ethernet IP, and then on the other side of the gateway it's talking to 3 Modbus devices. So there are hundreds of different Modbus devices we could use to communicate to a thermostat like this, but again, this Prosoft device is uniquely designed to talk easily with Rockwell PLCs, Allen Bradley PLCs, and Prosoft is considered an Encompass partner of Allen Bradley or Rockwell, which means they integrate really well with their stuff, and they have a good relationship. So Devices like this are usually called communication gateways because basically it gives us a way to communicate from a compact Logix to these devices. So if we could go direct to these devices, we would, but since they don't talk the same language that compact Logix talks, we need to get somebody in the middle. Sometimes it's called a translator. Usually it's called a communication gateway. So one thing I should clarify again is that Allen Bradley PLCs do not communicate via Modbus natively. There's a couple exceptions. I think with MicroLogix can be set up to communicate Modbus, but it's not a super simple setup. Okay, so now let's take a look at how to set up some Modbus commands to talk to the thermostat we introduced earlier. So we're going to get into the nitty-gritty of how Modbus commands work and how you can set them up to talk to a device. Okay, so this is Prosoft Configuration Builder. As you can see, the app just looks like that when you've downloaded it, and you can get it for free from prosoft-technology.com. Just FYI. And if you go to products, Prosoft software, and scroll down here, Prosoft Configuration Builder. So this is their main tool for configuring Prosoft devices. So we've got the software open. So what we're going to do is define a module in this project. So we need to, we'll just double click this default module. And they give us the option to choose a module type. So there's a bunch of different product line filters. This one is closest to what we need, the PLX30. So if we select that and then we choose the exact type, PLX31 EIP MBS is the one we want. So that's an Ethernet IP to Modbus Serial Communications Gateway. That's what we want. Ethernet IP is what the Allen Bradley PLCs talk, and Modbus Serial or Modbus RTU is what our thermostat is going to talk. Alright, so we have a new project or a new module in our project. And this kind of looks similar to the I/O tree in Studio 5000 Logix Designer. So the main thing we'll be working with here is setting up our Modbus commands. So let's open up MBS port 1. So this is MBS side of the gateway, which is Modbus, stands for Modbus. And we will choose Modbus port 1 first. So there's really a couple important things in this list, and then a lot of them will just be left at defaults, but there's several things we need to change first. So first of all, we want this port enabled, yes. Next, we need to choose whether it's going to be RS-232 or RS-485. So RS-232, real quick, is basically designed to communicate only between two devices. But we want to communicate, in this case, we really only need to communicate between two devices. We could use RS-232, but most Modbus devices work best with RS-485 because then you can daisy chain or link a bunch of them together and have one master that talks to all of them. So just to give you an idea of what I'm talking about, you've probably seen these old serial cables that have the 9-pin connector, and might be on your old laptop or your old desktop computer, and it's just a cable that goes from your computer to one other device, maybe a printer or a scanner or a fax machine or something like that. And in the PLC world, you'll still see these even today on newer devices, or the industrial automation world. Unfortunately, they still make devices with these. I don't know why. But as you can see, you can only connect one device to one device. So 2 devices total. So you got a master and a slave. That's it. With RS-485, you use wires and you land them and jumper them from device to device like this. So you got a positive, a negative, and a ground. And you just jumper them together like this so you can have as many devices as you need. Now some devices will only handle so many, but as you can see, you can do more than just a one-to-one communication. So that's the advantage of RS-485. So moving on here, we're going to say in our example that we're using RS-485, so let's select that. And then we choose the type. So this can be either master or slave, and this is the type that we're defining the Prosoft to be. And so in this case, we want the Prosoft to do the work, to do the commanding, to do the reading and the writing, and so it's going to be the master. And the thermostat will act as the slave. Okay, and then the protocol by default is RTU, which is just your basic Modbus serial protocol. And then you can also choose ASCII, which is a little different. And truthfully, there's not a lot of devices that use the ASCII format, so you'll just use RTU. And then the baud rate is another really important one. Actually, let's go back to Enron Daniels, just a heads up. I always leave this at defaults, but you can change it to yes if the device you're talking to has a certain float data type that you need to communicate with. But usually default is fine. And we'll get you talking to most devices and get you the data in the format that you want. Okay, so baud rate, as I said, is a big one, and this is just the speed of the connection. Okay, so how many bits per second are we sending from the master to the slave, and how many are we expecting to get back bits per second from the slave, so on. So as you can see, there's several different speeds here, slow as 600 all the way up to 115,200. It depends. Your slave device needs to be able to support whatever you choose here. So some slave devices only go up to 9600. Some will go much higher. But I pretty much have found that 19.2 is usually pretty fast and works well with almost all devices. So 19.2 is a good place to be. So just to verify, what you need to do when it comes to baud rate is whatever slave device you're talking to, you need to verify that it can talk the same speed or the same baud rate. So I'm in this PDF for this thermostat we're using for our example, and I'm going to search for baud rate. Okay, so it says the baud rate is selectable between 9600, 19.2, blah, 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 blah. So it looks like it goes all the way up to 76.8, which I'm not sure if that's even an option here. Yeah, it doesn't look like it has that, but it does support 19.2, so we'll just go with that. And I don't recommend going slower than 9600. 9600 can work pretty well if you're just talking to one device or something. But if you get slower than that, it gets painful. Okay, so the next three items, parity, data bits, stop bits. I usually just leave these at default. Again, these are usually selectable in your slave device, so you want to verify that they're the same. Same setup in the slave device, meaning parity is none, data bits is 8, stop bits is 1. And you can always look in the Prosoft manual if you want to learn more about those items. And then especially these other items down here. We're going to leave all of these at defaults. I recommend to go to prosoft-technology.com to download the manual for this particular module if you want to learn more about these settings. But we're going to leave them at defaults and click OK. So now let's open Modbus Port 1 commands. and we'll create our first command here. So we'll add a row. So we have several columns here. I'll stretch this out so you can see all of them. Enable internal address, pull interval, reg count, swap code, node address, Modbus function, Modbus address, and comment. So we've added a row, so now let's edit this. So this is one command to our, double click it, to our thermostat. Okay, so the first one we have is an enable. Again, this is just real simple, whether the command is on or off. And then there's a couple options if it's on. So obviously disabled would mean it's off. Continuous means it just keeps running. It will send the command to the slave device, and then it will send it again, so on, and just go forever. That's usually what you want, but in some cases you want event, command, or conditional, which if you're writing to a device, it can make it so that when something changes in the PLC, you could then say, okay, now I want to send a command to the slave device. So those are a little more advanced. You can read a little bit about that here in the configuration, or obviously again more in the manual. So we're going to stick with continuous. And then internal address is important here. This is where the data is being stored in the Prosoft. So the Prosoft has its own database where we store data that we get from our slave devices, or where we store data that we want to send to the slave device. So this is a gateway, so it's where we hold the data that's coming from the PLC or that we want to go to the PLC, and likewise the data that's coming from the slave device or that we want to send to the slave device, which could be a PLC, by the way. Not to be confusing, but your slave device can be a PLC. In this case, our PLC is a compact logic controller, and so it's not a Modbus slave device. Okay, so if we are going to read temperature again from the thermostat, that's our goal, we want to read the room temperature, we need to place that somewhere in our module. So we're going to put that in internal address 0, which we don't have to, but this is our first command. We're starting from scratch. We might as well use the first available internal database address, which is 0. So we're just going to keep that at the default. And then the PLC will read that thermostat value out of the Prosoft's internal address 0. Okay, the next item we have here is the pull interval. So this is basically how fast we want to send the command. So if continuous is set, then we can say that we want it to run continuously, but maybe we don't want it to run as fast as possible continuously. Maybe we want it to run every 10 seconds or every 5 seconds. So you can change that there. You would just change it to 5 for 5 seconds, 2 for 2 seconds, and so on. We'll leave it at 0 so it goes as fast as possible. Next, we have reg count, and this is the number of registers we're either writing to in the slave device or we're reading from in the slave device. And this is going to depend on which function code you choose here, which we'll get to in a minute. But one will always work. So if in our case we need to just talk to one register or one address in the slave device, the room temperature, then we're going to leave it at 1. Keep it simple. Okay, next we have the swap code, and this is has to do with if you need to swap bits in the register. So if you're getting 16 bits, maybe you need to swap the order of some of those bits so that you get the value in the right format on the PLC end. So that's a little more advanced technique that you have to do because some slave devices put the data in a certain format, whereas when you get it to the PLC, it wants to see it in a different format. So in this case, we're going to assume that it comes in the right format, so we're going to leave the swap code as no change. Okay, so now let's look back at the manual for the thermostat, because we want to see whether we need to scratch that. Okay, so next is the node address. So this one is pretty simple. We need to know what the address of the slave device is, and that can be anything from, I'm trying to remember here, I think it's usually 1 to 247 is what it says right here. So the slave device, you can have up to 247 devices on a Modbus network technically. But we just need to determine what node this thermostat is at. Since there's only one device on the network, one slave device at this point, we're just going to assume it's node address 1. That's fine. Okay, so next is the Modbus function code. Now this is really important, and this is where we're going to go back to the thermostat manual and take a look. So basically we want to find the room temperature, and I've already scrolled down to this page here and found that built-in temperature measurement is at register 100. So I did some searching in the manual, and it looks like built-in temperature measurement is the basic room temperature that the thermostat reads. And it's at register 100. So as we can see, it's saying function code 4 is what we need, read input registers. Okay, so let's go back to our manual. So right now its default is selected function code 3, read holding registers. We need function code 4, read input registers, right? Because that's what it says right there. Okay, so that's easy. And now the next thing we need, which we already found as well, is what address in the slave device are we reading. Okay, so this is different than the node address of the slave device, so that can be confusing. The node address is where the slave device lives on the network. Is it 1 or is it 247 or somewhere in between? The Modbus address in the device has to do with the database that lives inside the device, and those are the different values that you can read from the device. So room temperature, calling for heat, on, off, things like that. And this map tells us what is available as a Modbus address in the device. So there's a ton of things we could read: current calculated set point, thermostat current mode, whether it's in heat mode, cool mode, eco mode. I guess these are different: comfort, eco, off, boost. We can read the relative humidity measurement, the alarm state, so on. We just want the built-in temperature measurement, so that's easy. We're going to put 100 in at our command here for the Modbus address and device. Okay, and then we'll add a quick comment: thermostat room temp. Click OK, and we click OK, and that is the end of setting up a command to read a temperature from this thermostat. So you could go buy this PLX31 from Prosoft. It's about $700. Maybe you've got one sitting around at work. And you could go buy this thermostat. I'm not recommending that you do, but you could if you wanted to play with this more. 6th Sense SRT-P50 programmable touchscreen thermostat. And you could wire the two together, and you could set up this command and see if it works. So that's all there is to it. That's a great intro to Modbus configuration. Hope this was helpful. Hope it takes you one step closer to becoming a confident PLC programmer. And don't forget, if you need more information, more PLC programming training, stay tuned for more videos, subscribe, and you'll get notified of those. And then also you can head over right now to myplctraining.com, get our free PLC cheat sheet, and get some emails from me on how to take your career to the next level. That's it for now. Thanks.